to present you our work on creating friendly humor through generative techniques. And first of all, the disclaimer, all the intend to offend anyone. So we had a question, how can we train large? Answer was yes, like we took Mistral model and fine-tuned it on the first English dataset, and we got awful results. Like all the jokes generated were awful, they were very dirty, they were on politics, they were so offensive that we cannot show you them. So next questions were, can we train large language model to make jokes ethically, so to create some friendly humor that can be shown to the wide audience. So the beginning was finding the appropriate data. We searched the internet to find English corpora and Russian corpora. For English, the picture was very good. There were a lot of data sets with jokes scrapes from the web, largely from Reddit jokes thread and from the web page Pun of the Day. So we concatenated all the sources that we found. For Russian, the picture was rather different. There is only one open source dataset, Fun, curated by the Pavel Braslavsky team. It dataset included all the other sources, such as Stiglitz and some other more smaller datasets. Thus, we obtained the Fun collection as the base of our Russian part of the corpora. The weak points of the existing datasets were quite obvious. There was noisy data, because in English, in Reddit, some comments are somehow deleted or so on. So a lot of items were with some missed words. There were non-latent characters. There were very long items, very short items, so we deleted them. Also, there were many overlapping items, because we concatenated many data sets, and of course there were exact duplicates, so we removed them at the first step. But there was a high number of implicit duplicates when one joke was reformulating by many people. So the difference was like 1 or 2 words, but the sense was the same, and this could lead to overfitting our comic model. And as I said, many of jokes were toxic and offensive, or in some way discriminatory, and we wanted to remove them all. So yeah, for English, we concatenated all the existing data on Kaggle, and for Russian, we took dataset Fun. Here are some examples of the noisy data that we deleted. We also removed all the jokes of length more than 150 symbols, and very short ones. Yeah, and then we proceeded with the filtering. We intend to delete all the toxic ones, toxic items. Thus, we employed toxicity classifiers, detoxify. For English, it worked very good. It is trained on tweets, toxic tweets. Thus, it is sensitive to obscene lexic, and probably that's all. And Russian representation in this classifier was rather small. Thus, we had to employ another toxicity classifier, Robert, and concatenate the results. And we chose manually thresholds and deleted all the jokes that were toxic. And then we started with the duplicates. We used SentenceBERT to make embeddings for each joke, and measured the cosine similarity between the jokes. Chose manually the threshold, and left only one duplicate from each bunch of reformulating one joke. And here are the examples. And we could have thought that it was the end, but after scrutinizing the dataset, we found that there were so many implicitly inappropriate jokes, like when with good words there was said something about drugs, alcohol, and so on. And we used the Berta zero-shot classification. We had 6 labels: neutral, drugs, alcohol, racist, politics, and offensive, and we deleted all the jokes except neutral ones. But it also wasn't enough. To understand better the quality of our data, we employed topic modeling. We used their topic model with k-means algorithm, and we divided each dataset, English and Russian, into 100 topics. And here are the example. Probably the letters are quite small, but the highlighted topics were, as such, we deleted. So some about racist jokes, some about diseases, and other sensitive topics. And that was good enough. We decided that our dataset is clean enough, it's ethical, and there are still word jokes. So we had to measure how our dataset is good. So we asked annotators through our Telegram bot to rate each joke on the scale from 1 to 5. And also we asked them if they find this joke inappropriate. And here you can see the distribution of the average score of the jokes. Each joke was annotated by at least 5 people. Well, the manually part of the dataset consisted of 1,000 jokes for each language. As we can see, our annotators were very strict, especially for Russian jokes, probably because the majority of them were not native English speakers. Thus, the English annotation may be biased. And also, it is the question of the very nature of the humor. Like for English, it is more common to find somewhere a joke alone, like a short joke. And in Russian, there is usually a context and so on. And when we see a short joke or anecdote without a context, it may seem not so funny. But yeah, that is what we have. Here is the short outline of the pipeline for data curation. In the end, we got corpora in English and in Russian, with the golden part manually annotated. We publish the average scores for each annotated joke and each rating from each person. And we also trained a binary classifier to annotate the remains of the data sets, binary if a joke funny or not, and we also publish it. Well, as soon as we got the data, we started fine-tuning large language models. Here are the settings that we used. We fine-tuned Llama 3.18 billion parameters. We chose this rather small model because our dataset was not big enough to train the bigger model, and also we wanted to obtain lightweight model that can be implemented in some multi-agent system, because taking just very large model is not so fun. So we fine-tuned it with low-rank adaptation. It's LoRa adapter. So despite changing all the weights on each layer, we train some approximations of low rank. In our case, we had 4 rank. Well, and this was the first model. Secondly, we used this fine-tuned model to align it with our golden part of the dataset. Every average rating of the jokes, manually annotated, was mapped to 0 to 1 scale to get soft labels for further sequence classification. And we trained our model on this with binary cross entropy as loss function. So we got the second model supervised, fine-tuned, and aligned with human decisions. We thought that that would help a model to understand better which jokes are more funny and which are less. Then we got just pre-trained Llama 3.18b instruct and asked it to generate 100 jokes. We generated 100 jokes for each of the models. So the first one's fine-tuned and the second one fine-tuned and aligned. And we employed temperature of 0.5 because the jokes was good and they were quite diverse. But when we started working with pre-trained instruct model, it tended to generate the similar jokes. Thus, we had to increase temperature until 0.9. So it was a very hilarious thing. And we used sentence BERT with cosine similarity measurement to generate until we have 100 different jokes, because really there was a bunch of jokes that probably model learns in training data, and it repeated it. We did the same thing with GPT-4o. It also tend to repeat the same jokes. Thus, we generated a very big amount and chose 100 diverse jokes. Then we randomly sampled 100 jokes from unfiltered datasets for English and for Russian, and from our filtered CleanComedy dataset. And again, we asked annotators to rate the jokes. And here are the results, rather mixed. So there were 100 jokes for each setting, for each language, and each joke was rated by at least 3 annotators. The clear results that we can see is that the toxicity rate of the clean dataset is twice less than unfiltered one, and clean jokes are also more funny than toxic ones. Well, then for English, GPT-4o worked even better than human jokes. It was funny. For Russian, it wasn't so good, but still GPT-4o outperformed all other generated jokes. Our fine-tuning didn't work well, probably because we didn't have enough data, but the process was very hard. Or probably the models were too small, and we shall work with some larger models. Well, and the main contribution of our research is the CleanComedy dataset with manually annotated parts. It's a novel and ethically curated dataset for further human generation researches. So far, large language models do not produce jokes as effective as people, and probably because it is rather human thing, this creative humor. Well, thank you for your attention, and I would be happy to answer to your questions.
Thank you, Svetlana. Do we have any questions? Yes, please.
Thank you for your question. Thank you for your talk. I have a question about your data. So you show us graphics with how funny were jokes with human annotation. Did you check for correlation between joke being funny and it being inappropriate?
Well, our annotators saw only filtered data because it would be quite difficult to give our volunteers to watch hundreds of inappropriate jokes. But in the end, yeah, we see that our annotators rated jokes from unfiltered dataset as less funny than clean dataset, both in English and in Russian. So we guess that people do not really like the high amount of dirty ones.
Okay, thanks.
Thank you for your presentation. You said that you trained a model to evaluate how fun joke is, or
Well, yeah, classifier, but I do not present it here because it's not superior, but it works, and we publish it with our dataset.
Mhm. So can you say now, does this model think the joke is funny? In how many, how to say it? How good is it? So are annotators really better than this model or not?
Well, our annotators gave us the rate for each joke on a scale from 1 to 5. And it is rather curious question about the annotation of jokes because we saw different approach to this question. Usually it's a binary annotation like 0, no, not funny, and 1 is funny. Why do the jokes with label 0 are in the dataset of jokes? It was our question. So we think that all the jokes in our dataset are actually jokes, so we don't have 0. And we wanted people to rate how funny the joke is from 1 to 5. And then we trained classifier, BERT classifier, with this manual ratings to predict the soft label and then put a threshold to divide it into 2 categories, not so funny and very funny. So we call it like this. And of course, this model is worse than human evaluation because humor is very subjective. Thus, we cannot think that a classifier would be better.
And do annotators have different scores? How different scores are?
Well, here is the distribution of scores in clean dataset, but I do not present here an illustration of the distribution of ratings of generated jokes, unfortunately. But it's more or less the same, like average score is 2.5 or 2.7, something like this.
Okay, thank you.
Thank you very much. I should say that I am really impressed by your fundamental approach to such domain. So I don't have a question, I have a comment that your presentation really lacks examples of what your specifically trained models generated. So the audience also can look at this and say, okay, large language models are not, don't have enough humor at the point, or okay, they're near to that point. Thank you.
Thank you very much. Did you do something with the political bias of the jokes? Because, you know, when you go to the top of the anecdote rule, usually you see a lot of political jokes that have a very lot of likes, but probably not because of they are really funny, but because of agreement between the some user of the anecdote rule and the political message incorporated inside the joke.
Yeah, the political jokes was a very big part of the rated jokes, and we removed them all because we wanted any questions about our preferences.
Thank you very much.
So we found them by the Berta classifier, which works quite good with named entities of the politicians.
Thank you for your presentation. On your slide 20, you just said that you use at least 3 annotators for each joke. So my question is, how did you measure the rate of toxicity and humor? You just take average of the 3, or maybe you have something like Fleece Kappa to have statistics about in controversial jokes, because humor is very unique thing. So someone could pick like 1, another one could pick like 5. So yes, the question is, how did you measure this?
Yeah, thank you. For humor score, we just measured the average score of 3 annotators, and for toxicity percentage, Fleece Kappa won't work well for 3 people. Thus, we employed just the majority rule. If the 2 people think the joke is inappropriate, so the joke is inappropriate.
And so, which Fleece Kappa rate did you have?
Well, as I said, we didn't use Fleece Kappa because it's a statistical method. And it won't work for 3 people well. So maybe it will work, but it won't be better than just majority rule.
Okay, got it.
So I think it worked well for 5+1.